Everybody, it's really nice to meet you. As Taylor said, my name is Essie, and I'm a product manager at grid.ai. We are actually based in New York City. I'm not sure if you're all familiar with the company grid.ai. We're based in New York City. There are about 30 of us. We are distributed across several different countries, and we're really excited to actually share this journey through Grid with you today. As Taylor mentioned, we will just be walking through the platform today. If you have questions, feel free to note them down or send them in the chat, and then we'll address them at the end. So here is the agenda. So I'm going to start off by talking about Grid, just giving you a brief introduction to what Grid is and what problems Grid solves. And then I'll spend the majority of today actually in the Grid platform, giving you a demo of all of the elements of Grid, how you can interact with the different elements and all of the really cool things that you can do with Grid today. And then we will transition to Q&A. All right. So starting with the ML limitation. So why are we here? Why is Grid here? What is the reason for which we're all seeking out a solution? So there are several different areas in which there are limitations today for ML. So complexity is one of those. So there really is this like centralized focus of AI in a lot of large AI labs today. However, it's not very accessible to an individual researcher unless you're working at one of these labs. And even when you are working on one of these labs, there are a bunch of disparate ML systems that don't really work that well together today. And there's a slow iteration of ML models for several different reasons, because you're sharing resources, because you don't have access to that much resourcing, and you're sharing with a ton of different individuals. Speaking of sharing, another limitation today is that there is this desire to collaborate in the ML realm. However, there are not that many great tools for collaboration and for sharing information amongst teammates. So we aim to essentially provide a solution that allows you to share information, analyze with your teammates, thereby improving team efficiency and allowing you to iterate much more quickly. There's also a lack of insight, right? So you're running these training jobs, and you want the ability as a researcher, as an ML engineer, even just like a prototyping engineer, you want the ability to experiment freely without really having to worry about like the ops and without really, while still keeping in mind, cost and budget. These things do matter, as well as compliance. So you want some insight into the tool that you're working with, and you want some insight into your spending and the actual impact of the experiments that you're running. And then lastly, there's also this complexity to expand, local to cloud. If many of you are currently training, in Colab, or maybe you're using some other tool, or maybe you're training locally, or with a lab using your lab resources, you'll understand that it can be frustrating sometimes if you're just focusing on the research itself, and you get slowed down by trying to understand the complexities of the cloud, of access, or of orchestrating, of accessing resources in the cloud. When your code changes, having to account for that. And then also, of course, resource availability is a really, really big one. So these are the limitations. And so Grid is a solution that allows you to train hundreds of machine learning models on the cloud at rapid speed from your laptop. And so I'll talk a little bit more about what that means, and I'll hopefully illuminate for you today just how easy, how simple it is to do that. Talking a little bit more about the advantage of Grid. So what we're doing here is really just trying to empower you to focus on the machine learning, just focusing on the research, focusing on just that iteration loop that you're most likely familiar with, and not have to worry about the underlying infrastructure. So we want to just give you the power, the compute power, to run at scale. And that's what we're here for. So these are our most common user personas: the model developer, researchers, data scientists. A lot of these names, like data scientist, is kind of an overloaded term. It can mean something different depending on where you are. If you're at a small company, at a large company, something that's missing here is also the ML engineer. So there are, depending on where you are, the ML engineer also can just be focused on doing research, a combination of research and also like productionizing models. The idea is that we're empowering anybody that does training or experimenting or that needs compute resource power for scaling out models. That's what our solution here is for accelerating that productivity today and enabling you to build applications much faster than you are today. I also have listed here team manager. So what you'll see when I go into the demo is that we also offer collaboration in Grid. And so there is this notion of overseeing researchers, experimenters, data scientists who are running these experiments, overseeing kind of, the work that they're doing, and monitoring, like as it says here, monitoring the spend, the workload, and all of that. And so that is our intention in offering this collaboration feature. Okay, so I'll just go right into the demo and we'll spend a good amount of time here. It'll be comprehensive and I'll try to point out as much as I can. However, I'll talk about some additional resources at the end and we'll talk about questions at the end as well. So first things first is accessing Grid. So you can come directly to platform.grid.ai. You can also just go to our website, grid.ai, and then just choose login. Login today functions as, just a login if you have an account. If you don't have an account, don't worry about it. When you log in for the first time, it'll take you through a registration process. And upon logging in, you'll have free credits that you can use for experimenting for the first time. So today we support Google and GitHub as login mechanisms. I'm going to sign in with GitHub. There are many advantages of signing in with GitHub, which is that now I am already integrated, like my GitHub account is already integrated with Grid. And what that means is I now have access to like any public repos that I have in my GitHub account. You do also have the ability to enable private repo access. So I'll show you how to do that. Before I do that, I wanted to point out this is the landing page when you log into Grid. This is the dashboard view. And so this is essentially a summary of all of your activity, not all of your activity, but your latest activity in Grid. So you'll see here that we have some metrics around costs related to runs and interactive sessions. I'll talk about the difference in a minute. We also have just your latest runs summarized. And as you can see, I'm running on a team right now. So I have my own runs that are showing up here. I have runs from some of my teammates as well. And I'm also getting a summary of the statuses. Like you can see, Q means queued, R is running, we have completed, stopped intentionally, or some sort of failure. And then I also have my active sessions. So I'll talk about what sessions are, but you can see that I have a session running. I am the one that created it. This is the name. And then we have a bunch of options here that I'll talk about later as well. Wanted to quickly draw your attention to this little avatar here, and like this section summarizes how many credits I have. Clicking on credits will allow you to add more credits if you want. We have a pretty neat integration with Stripe, so it's really easy to add more credits if you wanted to. Clicking on or hovering over this avatar here will allow you to go to your settings. And I did want to point out that by default, if you log in with GitHub, we automatically grant access to your public repos. If you log in with Google, you can still come to this section and enable, connect your GitHub account. For private repo access, you actually have to manually grant access. And now I have access to my private repos as well. And so that means a few things. That means that I can go into a session, which I'll show you like in a second. You can go into a session and you can just clone any of your repos, public or private. You can start a run and I'll show you what that looks like, but you can essentially just choose a script from any of your public or private repos as well. So it's pretty cool, pretty easy once you just click that one button. So another thing that I want to note, if you haven't used Grid before, maybe you just want a quick demo. So we have here our Hello CFAR 10 demo. It's really lightweight, really easy. It walks you through, if you click this button, it walks you through how to create a run, and it pre-fills all of the fields for you. So this is like a great place to start if you want to see an example of a run. So before I go into runs and sessions, I want to talk about data stores. Data stores are very important. The advantage of a data store is that it enables you to upload your data to Grid, store it in a data store, and then have immediate access to it from any of your training jobs. You can also mount it in a session, which I'll show you in a second. But this pretty much, it eliminates the need to download data every time that you run a training script. So you now just have this data sitting here and just like immediately accessible to your training jobs. As you can see here, I've created quite a lot, quite a few data stores. And I also have access to my teammates' data stores as well. You know, I can't delete it. You know, I can't modify their data store in any way, but I can clone it. I can create my own version of it, which I can manipulate in whichever way that I choose. And I can also just use it. I can use it in a session. I can use it in a run. So it's really neat for collaboration. You don't really need, like, each individual teammate doesn't need to go in and download the data every single time, doesn't need to necessarily upload the data every time either. So I want to walk you through what it looks like to create a data store. So in the top right-hand corner here, you'll notice we have this new button. So this is where you'll go to create any new activity, a new run, session, or data store. And it's pretty simple. You can name your data store, whatever's intuitive. And then you have the ability to upload a file or a folder directly from your local system. You can also provide a URL here as well. And I want to note that this is just one way, right? So we also have the Grid CLI, which I'll talk about a little bit in depth once we get into the sessions and the runs. But you have the ability to create data stores as well from the CLI, which some of our users tend to prefer because they're used to working that way. So I will now go into sessions. Okay, so I have a few sessions that I've created. My teammates also have some sessions here. You'll notice that the majority of these are paused, which is a really cool feature because the idea is that the session is a place where you'll go and prototype. And I'll show you in just a moment when I open Jupyter Lab. But it's really, the way that I tend to use sessions is that I will mount my data to a session, and I'll go in and I'll immediately like clone a repo, and then I'll run my code, and I'll make sure that the code works, and I'll make sure that, you know, the data is prepared the optimal way. I'll make sure that everything is functioning the way that I would expect before I actually launch a sweep or a run, which we'll talk about a little bit later. So when I'm not actively in the session doing this work, I like for it to be paused. I'd like to not be, you know, charged, but I still want to keep my data. I still want to store the session state. And so that's what pausing is for. That's why the majority of these are paused. I have one running that way I can show you what it looks like to be in a session. I also wanted to call out, you know, like if you wanted to interact with this table, you can look at the details of the session. It'll tell you specifically the instance type it was started with, some additional information around the session. And then you have several different ways to connect to the session. So you can connect through SSH, like from your local machine. We also have a VS Code integration. So if that is an IDE you're familiar with or that you work with, it's really cool. You can actually connect directly to your session from within VS Code. We also have, you know, just SSH, as I mentioned, just like through the terminal, and then Jupyter Lab, which is one that I use quite often. And so we'll wait for this to start. So you'll notice a few things once Jupyter Lab starts. One thing I want to point out is that I have this directory called PyTorch CNN. So this is my data store that I actually mounted when I was creating the session. And I'll take a step back actually and show you how I did that, just to demystify a little bit. So I go in, create a new session, give it a name, and then I have access to attach any of the data stores that have been created in my environment. So that extends to data stores that were created by my teammates as well. And so I chose the PyTorch CNN dataset. You also have the ability to select a version. So like, let's say one of my colleagues or one of my teammates created a data store and then I created another version of it, or maybe they made updates to it. You have the ability then to choose which version of the data store you want to mount. And then you can also specify an instance type. Maybe you want one that has GPUs on it, for the sake of quickly iterating. I actually just kept it, I like to keep things low cost, especially when I'm just experimenting. So I just kept it at CPUs. And then you can just start the session, and it's that easy. It takes it doesn't take that long, a few minutes sometimes. And then once you've started it, you have access to connect through Jupyter Lab. And then, I think Jupyter Lab is probably something that's a familiar tool to many of you. You have access to the notebook. You can also just load a terminal directly. It's really awesome. So a ton of advantages here. Since I'm logged in already through GitHub, I don't need to do anything additional to add keys or to make sure that I'm authenticated. I can actually just from my notebook directly just clone the directory I need. Then I have access to my scripts. I already have my data here, so you can just start working immediately. Another advantage is that you have access to the grid CLI already. And so, you can come in here and type in grid help, and then you'll see all of the commands that are available to you. And once we get into runs, you'll understand like the real power of this, which is that you essentially can, you can load artifacts in here if you wanted to. You can actually create training runs from here. You can create data stores from in here. And so you can have complete access to the grid CLI and capabilities with the added advantage that you're running on an instance with GPUs. All right. Okay. So now I will move into runs. So once you've gone through and done your prototyping and you're sure that that your code runs and your environment is set up the way that you need it to in order for the run to work, you can go into runs. And so when you come into runs for the first time, you'll notice like a lot of these screens are blank. That is by design. So the first thing that you'll want to do is select a run. So I'm going to go ahead. I'll select a few runs so we can see what happens when I do that. So I now have, I selected this run, which has one experiment. This one has 4 experiments. So I now have these 5 experiments that are displaying in this experiments table. I have the ability, like from this run table, you can, you can click on each of these statuses to sort by the status. Let's say you wanted to see like all of the completed runs at the top. You can click on this little C icon here, and it'll show all of the completed runs. You can do the exact same thing for experiments. You can click on any of these fields to sort. By default, I'm sorting by the run name. You also have the ability to take actions on selected experiments. So right now the actions are delete or stop. And I wanted to point out as well that we have some metrics that are being displayed. So the metrics that are being displayed up here correlate directly to the experiments that I have selected down here. And you'll notice, as I select additional experiments, these charts are updating in real time. You also have the ability to make it full screen if you want to engage and interact with these charts at a more in-depth level. We also have artifacts. So you'll notice I have selected 3 experiments right now that are running. I have artifacts for each of these experiments that I can actually download directly from the UI. I will say that what we have noticed is that a lot of our users enjoy engaging with artifacts through the CLI. You can actually download all of the artifacts for a run from the CLI. So it's a little bit, it's more of a programmatic approach, and it allows you to, it's a little bit more robust through the CLI, I'll say. In addition, so let me go back to the metrics. So you're seeing right here, these are the default metrics that are coming from Lightning. You have the ability to, by clicking on columns here in the experiments table, you can specify if you want to see the specific values for each of these metrics for each experiment, then you can enable that here in this menu. So right now I don't have it turned on just because I'm using the metrics here and I wanted to keep this table lean, but you do have the ability to specify which fields you want to see at any given point in time. I would like to also now show you some more detail that you can get about the runs and the experiments. So I have this run that's running right now. It's a basic GAN model. I'll go through how I created it and how you can create a run in a moment. To look at the details, you click on these three dots here. And you'll see we've summarized a bunch of information about this run. So this run, as you can see, it's quite expensive. I created this run using GPUs. I also used an on-demand instance as opposed to a spot instance, which I'll show you the difference when we go through the run flow. I also get a summary around like the instance in general, and then I get some detail around, if I wanted to reproduce this exact run in the CLI, I could just copy this command and just paste it in my terminal, provided that I already have the grid CLI installed, which is very simple to install. It's about 3 commands to install. I also have some additional features here. I can clone the run, and cloning the run is as easy as literally clicking this button. And what it does is it generates the exact same run again with all of the fields pre-populated. And I also have the ability to share this link with one of my teammates or somebody else that's using Grid, and they can very easily reproduce the run. Scrolling down, I now have also a summary of each experiment. So I can click on this experiment to get the experiment details, or I can come down to the experiments table. And in the same way that I looked at the run details, I can access the details for the experiment. Now for each experiment, I have a summary of exactly what is being run on that instance, as well as what artifacts were generated on this specific instance. Build logs are, these are logs that essentially give you information about what's happening before the training starts. I actually have an experiment running right now. So what's more, I'd say, relevant to me at this point are the standard out logs. And so they're generating right now, but you can see now through the UI, like that training has started, and you get some instance into what's happening under the hood. Just also wanted to highlight that, through the CLI, it's super easy. So we try to illuminate like how you can do things both ways in the UI. So if you're somebody that likes to use the CLI, it's very simple to get logs. Just copy and paste this command. You can also view them in full screen. This is something that was requested by a lot of our users if you like to engage with the logs in this way. Okay. So now going back into the dashboard, 9 minutes, since my computer is blowing up. Spinning wheel of death. So as you can see here, as I mentioned before, we have the metrics, the default metrics that are being logged. If you're using Lightning, it's super easy to enable this and also to expand on this. 1 second while I essentially start a new window. Okay. All right. Okay, so we're back. Let me go back into runs and let me go ahead and select this run again. So I've highlighted a lot of capabilities that are available through the runs page. So now I'll actually go through the flow and show you how to create a run. So new run, you can name it something intuitive. So this is where you can actually, so I've used Grid quite a bit. So I have the repos that I use most frequently that are here as suggestions for me. You can also just specify a link directly to a GitHub script or repo. And what happens is, like for example, if I select a repo, I'm then given the option to navigate through the repo and select the script that I want to run. You can also attach a data store directly to the run. And so this saves a ton of time when you're iterating. You don't have to wait, especially if you have a large data set, you don't have to wait for the entire data set to download in order to train. And so as I showed before when we were creating a session, you can mount any of these data stores. You can also use spot instances. So I would like to show. So right now for this particular, I'm using one V100. It's $3, it's an estimated $3.21 per hour. The advantage of spot instances are that that cost reduces dramatically. So now it's at 96 cents per hour. And so you have the ability, if you're just experimenting, if you're running a large sweep and you want to get insight, if you want to just do some tuning, and you're really in that explorative phase, it might make more sense to use spot instances. And what this means, they're interruptible machines, right? So that means that at any given point in time, one of those instances could be killed. And it's a trade-off. So for that reason, these instances are much cheaper. But if you are just doing pure experimentation, then it's a good option. So I'm using spot instances. You also, by default, we're using the Grid cloud. We support additional clouds. If you're interested in connecting to your own cloud, then that's something that you can let us know about. That's something that we're in early access for today. We also have just launched multi-node training, distributed training, which I know is a feature a lot of our users and early access users are excited about. And it's very easy. So I'll give you an example. So let's say I choose an instance with 4 V100s. I then have the ability to specify the number of GPUs that I want to use per experiment. And you'll notice that once you get past the 4 that are available on that instance, you now get into the land of multi-node. So I can run it across 8, 16, 13, and this essentially distributes the experiments across multiple nodes. So we are actually in beta, in early access for this. However, it's available in the Grid community, so you can go try it out. Let us know if you have questions or feedback as we continue to improve and iterate on that experience. You'll also notice that we have this section here, which allows you to specify any arguments that you want to pass to your script. And so as I was showing in the previous example, you can specify something like a learning rate, and you can actually determine, like how many experiments you want to run, and you can specify a range of values that you'd like to essentially segment for the different experiments. You can pass in essentially any script arguments that you would pass in using Python normally to your script will be supported here. And so let me actually go back to the example that I had here. So if I go back to the details, you'll notice here, like a lot of these are defaults that you don't really have to worry about. For example, like the grid search is like the default strategy. You don't have to worry about the disk size. You don't have to specify a description unless it's useful to you. The key properties that matter here are the instance type, which I selected, the framework, I'm using Lightning. I'm passing in the number of GPUs to Grid, and then the script, of course. And then here I'm specifying a specific data set that I want to use, because in this instance I used one of our demo examples, which downloads the data. This would, the ideal experience is that you just mount a data set so you don't have to worry about this. And then, as I was mentioning before, specifying the learning rate here. And so this launched 4 experiments with uniform distribution. Very, very simple. So if I wanted to do this in the CLI, I would just copy this very easily, and it would be the same experience in the CLI. So that is pretty much an overview. There are a ton of new features on the way. We're always open to feedback. One thing that I didn't point out is that we also have a TensorBoard integration here. So if you're somebody that uses TensorBoard for visualizing your metrics, you can do that for your experiments. So what you'll notice that I just clicked a button, and what it's doing is it's starting up a TensorBoard instance. After that, you can select the experiments for which you'd like to launch TensorBoard, and it'll be as easy as just clicking this button here, and it opens TensorBoard in another tab. you have access to the same metrics and visualizations from within TensorBoard. We also have, this is one of my favorite features. I know it's quite simple, but we have dark mode. I like to work in the dark mode. For the sake of this demo, I kept it in the light mode just to make sure everybody could see everything. But yeah, we have great designer, we're open to feedback, ideas, anything that would make the experience even more fun for you, let us know. And so I will stop sharing for a moment. And then we can jump into Q&A. Let's see. Okay, so I see we have a few questions in the chat, or we have highs and hellos. Do we have any additional questions? Taylor, do you see any in the Q&A section?
Yeah, so now everybody would be a good time to throw any additional questions into the chat. We did have a couple that came in while you were giving the demo, Essie, so maybe we can work on answering those. So the first one is, what machine learning libraries does Grid come with?
So Grid is currently optimized for Lightning, PyTorch. We also support Keras, TensorFlow, and also Python as well. And scikit-learn, sorry, I forgot to mention that.
Okay, and then also they're wondering what cloud provider Grid is running on.
Today we're running on AWS, and you can easily just use the Grid Cloud, which is backed by AWS. We also support the ability to provide your own custom AWS credentials. If that's something you're interested in, feel free to let me know.
And then the last question that we have here is, how can I share my projects or experiments with other users? And I don't know if that was something that you'd covered, but.
Yes, so I covered collaboration briefly. I can actually, let me just share my screen and walk through that again as I talk through it. 1 second. Okay, so collaboration is a feature that is available for early access today. So if it's something that you're interested in, again, you can reach out to me, you can reach out to support at grid.ai. And we actually have a trial right now. So we're happy to walk anybody through what collaboration looks like today. So the way that it works is once we set you up for teams, essentially the teams tier or the collaboration product is I create a team for you in the back end and I add all of the teammates that you'd like to be on your team. And then by default, I'm not even joking when I say it's the click of a button. By default, you have access to view each other's runs, sessions, data stores. You can also you can clone each other's runs, you can use each other's sessions, you can use each other's data stores from within a session or a run. Default permissions make it such that the user that created the session or run or data store is the only user that can stop it, pause it, delete it. So, that's just like to protect the user that created the resource. However, as I mentioned before, you can engage with it in other ways. You can clone and create copies of them in that way. And yeah, so that's the default functionality that's available today. And we definitely plan on evolving on that experience. So if there's any feedback, feel free to share that with us. But as you can see here, as I showed before, right now I'm looking at all of the runs across my team. So, you'll see Robert here, and you have me, you have Mike creating different runs. I can actually take a look at logs and artifacts and metrics for Mike's run. I can clone it if I want, to create a similar run. Oops, sorry about that. I can do the same thing for sessions and for data stores as well. That's a good question.
There is another comment here, question. It says, could you briefly talk about how to access the data uploaded as a data store when the script is run? It looks like the data is available as a local directory, if this makes sense.
I believe so, yes. So just to reiterate on that question, You're asking, after you've created a data store, how do you actually access the data?
Yes.
Yes, okay. Yes, so once you create the data store, it's immediate, it's after it's, optimized and succeeded in uploading and has actually succeeded in Grid, you can attach it. So let me share my screen again. Maybe I should just keep my screen sharing. You can access it in multiple ways. So if you'd like to use it for training, you can create a run and select the data store. And by default, like all you really need to do at that point is just specify, like if you have like a script argument that's, like data dir or something like that, or path to the data, all you need to do is just specify the data store name, and then you have access to the files that are within that data store. You can also, from a session, when you're creating a session, you can mount the data store. So as I showed when I was going through the demo, when I created this particular session, the one that's called PyTorch CNN, I just mounted, I mounted the data store called PyTorch CNN, and then I can open up a Jupyter Lab instance. And you'll notice, and the reason why I'm doing this is because it's super clear through Jupyter Lab where the data lives and what the path is. Sorry?
No,
okay. Yeah, so, oh, sorry, I'm actually in a terminal. That's what I'm saying.
Terminal's good, that's what I'm saying.
Oh, okay.
That is the local path.
Okay, great. Thanks, Ari. I have a nice helper here. So you'll note that right now, this is like, the home directory. I also have access to each of these directories. PyTorch CNN is the data store that I created. So I can go into this and I see I have my script here. If I had additional directories, training, testing, validation directories, everything would be there. And you'll notice it's just a local path that you just have access to. So from directly in the session, you can access your data, and you can run training on it and manipulate it in any way that works for you, for your workflow.
So Curtis says thank you. And then we also have a question from Raphael, and it says, is it only TensorBoard that you can use?
So natively, that's a great question, Raphael. So natively today, we have that integration with TensorBoard where it's a click of a button, and that's the only one that we support. I'm curious to know what else you'd want to connect to. It's useful information for us as we think about evolving the product and adding more integrations. So feel free to share that.
One thing I'd also say, just real quick.
Feel free to say that loud.
Yeah.
So Ari is also going to answer that question.
Yeah. So one additional thing too, while there's the native integrations with TensorBoard, if you're running your scripts, you can also connect. So you can still connect out through your scripts and logs. Okay. So if you're using PyTorch Lightning and you have other loggers, those loggers will log where you want them to log to.
Thank you. That's a very good point.
He also just mentioned weights and biases.
Yeah, so that's a common one. And as Ari mentioned, you can connect to weights and biases from your script directly with the logger.
Yep, yeah. And we have ongoing conversations with them on that.
Yeah. You're welcome. Are there any additional questions?
I haven't seen anything else come up. We can give it one more minute here if anybody else has something.
Okay.
Maybe also, wait, Taylor, before everyone heads out, can you send Taylor the link to the platform so if people want to get started trying today, they can just click on the link, log in with either GitHub or their Google accounts, and if you click, you get those free credits that you just get up and started today.
Absolutely, yeah, we're definitely encouraging you to join our community. We are in Slack, so feel free to go to platform.grid.ai or grid.ai, either way. Create an account. It takes maybe 30 seconds, and then you can just explore. And then feel free to engage with us on Slack. Like we're all in there. I'm in there, Ari's in there, Taylor, like just pretty much all of Grid is in there. We have everybody that's in there is really open to answering questions, taking note of your feature requests or any feedback. We love jumping on like quick calls just to learn about you and what you're working on. So definitely encouraging you to do that and to let us know if you have any additional questions after this session. Thank you so much. It was really great to present this to you all, and I'm hoping that it was useful and that if you have any additional questions that you can reach out to us, and looking forward to seeing you in the community.